Same raw data. Same algorithm.
Team A, 91% accuracy. Team B, 58% accuracy.
Neither team touched the model. So what changed? That question is what this episode answers. Episode 19, Feature Engineering. Turning raw, messy data into something a model can actually learn from. Here's a tiny slice of a real dataset. Income is 1,000 times the scale of age.
Distance-based models get confused by that instantly.
City is text. Most models can't touch text at all.
And this n/a missing data crashes most models on contact.
Feature engineering fixes all three before the model ever sees it. First fix, feature scaling. Standardization centers your data at 0 with unit variance.
Use it for linear models, SVMs, and PCA.
Normalization rescales into a fixed 0 to 1 range.
Use it for neural networks, image pixels, and KNN.
Tree-based models like random forest don't need scaling at all. Let's watch one row become model-ready, step by step. Here's the row, age, income, city, and a missing value.
Step 1. Simple imputer fills that missing value with the column median. Step 2. StandardScaler rescales age and income onto the same footing. Step 3. One hot encoder turns city into binary columns.
All numeric. No gaps. Comparable scale.
That's what model-ready actually means.
One hot encoding turns a category column into columns a model can use. Each city becomes its own 0 or 1 column. Karachi is 1, 1, 0. Lahore is 0, 1, 0. And so on.
Never label encode nominal categories with 1, 2, 3.
The model reads that as an order that was never there. Missing data isn't one problem. It's several, depending on context.
Numeric column, a few gaps, impute with the median.
Numeric column, many gaps, add a was missing flag 2. Categorical column, impute with the most frequent value, or unknown. A column that's mostly empty, consider dropping it entirely. Sklearn's simple imputer handles the common cases in one line. In code, all of this becomes one preprocessor. Build a small pipeline for your numeric columns. Impute, then scale. Build a small pipeline for your categorical columns. Impute, then encode.
Wrap both inside a column transformer. One object, every column handled correctly, every time. If this clicked, subscribe. Imbalanced data is next. Same logistic regression, same dataset, different preprocessing. Raw features fed directly to the model, 58% accuracy. After the column transformer and pipeline, 91%.
The model didn't change.
The data going into it did. That's the whole lesson.
A few mistakes come up constantly here.
Fitting your scaler on all the data before splitting, that leaks test statistics in.
Label encoding nominal categories with 1, 2, 3, fake order. Imputing with the mean on skewed data, the median is almost always safer. Doing all this by hand instead of a column transformer and pipeline.
Every one of these is a leakage or encoding bug hiding as a model problem.
So which technique when?
Linear model, SVM, or PCA StandardScaler is close to mandatory.
Tree-based model, skip scaling entirely. Nominal category with few values, one hot encoder. Ordinal category, like small, medium, large, ordinal encoder with an explicit order.
Whatever you choose, fit it only on train inside a pipeline.
Quick recap before we go.
The problem: scale, text, and gaps all break models silently.
Standardization for linear models. Normalization for neural nets. One hot encoding for categories, no fake order. Median for missing numeric data, most frequent for categorical.
And all of it wrapped in a column transformer and pipeline.
Where we are in the series. We can evaluate a model, diagnose it, and now prepare its data correctly.
Episode 20, Handling Imbalanced Data.
Why accuracy lies to you when one class is rare, and what to do about it. Episode 20, Handling Imbalanced Data. Why a 99% accuracy model can be completely useless.
SMOTE, generating synthetic minority examples.
Class_weight equals balanced, the one-line alternative. Subscribe so you don't miss it.
Your challenge task for this episode.
Load any messy real-world dataset. Identify the numeric columns and the categorical columns.
Build a column transformer. Impute and scale the numeric ones.
Impute and one-hot encode the categorical ones.
Wrap it with a model in one pipeline.
Compare cross_val_score before and after feature engineering.
Bonus, try MinMaxScaler instead.
Does your score change?
Solution is in the repo.
Think before you look. Team A and Team B trained the exact same model.
Team A scaled, encoded, and imputed first.
That's the whole 33-point difference.
Episode 20, Handling Imbalanced Data, drops next. Subscribe.
Comment below. What's the messiest dataset you've ever had to clean?